dito sa end ng runway. So, yung original taxiway or the taxiway was already built, displaced then. May displaced area lang tayo dito for extra takeoff run. So, remember that the displaced threshold can be used for the takeoff run. So, pwede ka mag-take off. From here, you could ask the tower to backtrack. So, kailangan natin ng clearance to backtrack kung babalik tayo dun sa current active runway. So, backtrack ka kung sa tingin mo, need mo ng extra length ng runway upon takeoff, and it's upon your discretion. If hindi naman, you could take off from here. So, the displaced threshold can be applicable for a takeoff. However, for landing, you could never use yung ating displaced threshold area. You could only land and spot a landing sa ating threshold, and you could only aim on the threshold area. Kaya nga siya displaced, probably meron tayong obstacle approaching the runway. Kaya yan, naka-automatically displaced. Moving forward, we got the consideration or other consideration on getting our primary, secondary runway. So from the word itself, very self-explanatory naman, primary and secondary. So nagkakaroon tayo ng secondary runway or additional runway, usually to date or to obtain, sinabi ko nga kanina, yung usability factor na at least 95%. So pag gumawa tayo ng primary runway, yet hindi tama yung wind or hindi enough yung wind distribution doon, we will have to conduct a secondary runway in order to attain yung 95% na usability factor. Kasi po, nagkaroon tayo ng primary runway and then wala naman tayong enough wind distribution doon sa primary runway. Therefore, walang silbi or mawawalan tayo ng operation. We cannot take off with a lot of crosswind components. We need to be into the wind as much as possible. Kaya meron tayong, or we need to construct a secondary runway to obtain yung usability factor na 95% pertaining doon sa wind coverage or sa wind distribution. Of course, marami pang factors na kailangan ma-consider for us to build extra runways. But number one factor na nagiging reason to build instantly ng secondary runway is yung usability factor ng runway. So moving forward, or the last on the slide there, we got runways with stopway and clearway. Later ko na siya i-discuss. We have a specific slide for stopway and clearway and how to identify those. So let's move forward. Next stop is yung width ng runway. We got a table here for the width. Self-explanatory naman to. Ito yung minention ko kanina, Aerodrome reference code. Dapat familiar pa rin kayo from the prelim or meron, alam nyo pa rin to, Aerodrome reference code. So we have the reference code here in terms of the numbers 1, 2, 3, and 4. And ito yung A, B, C, D to F. And andito yung given na required width ng runway per reference code ng aerodrome na i-build mo. Of course, within the study kung ano yung mga aircraft na i-cater ng specific airport or aerodrome. Sir, bakit po yung ibang table or part ng table is voided? You could see here, voided na to, voided na to. So for example, here, voided na to, of course, kasi ano to if you could remember yung aerodrome reference code is paliit siya and palaki. So for example, for number 4, no need to provide ng data for AB since ito na yung mga smaller aircraft. So ito na yung magiging minimum natin for it. For reference field length 1,800 meter and over. For this naman sa maximum, so code number 1 less than 800 meter to. So ABC lang. So no need to get data from D to F. Since yung D to F, ito na yung mga commercial aircraft natin. Code number 1, 800 meters lang yung ating runway. So technically, hindi na tayo makakapag-cater ng mga aircraft so from class D to class F. So no need to provide data from here. So same with this. Code number 2, that's 800 to 12. If you could remember, wala na tayong needed data for larger aircraft since we could not cater them. Okay, so please have a or take note for the width of the runway provided by the law or for provided by the local authority. Next up is minimum distance between parallel runways. Self-explanatory naman given yung distance natin in metric or meters for parallel runway that has instrument and for non-instrument. We have here yung code number, yung non-instrument runway, naka-base siya sa code number, same as the width of the runway. On the instrument runway naman po, naka-base siya yung distance ng runway or two parallel runways, naka-base naman siya sa type ng approaches. So sa isang instrument runway, meron tayong mga types ng approaches dyan, modes 1, 2, 3, and 4. But no need to elaborate this for now. Sa aircraft operation na to and it varies really from time to time. However, ito yung major designation ng mga operation for an instrument runway. So we got independent, parallel approaches, dependent, independent again. And ito yung distance needed for parallel instrument runway. Minimum distance. Moving forward is yung slopes natin with the runway. So, with the actual construction ng runway po, hindi naman ito nako-construct perfectly. I mean, if you look into it, so it seems like perfect, but yung slope po ng isang runway is hindi not perfect. Masyadong mahaba yung kalsada or pavement na gagawin natin in order to perfect it or to have it a perfect slope. So, kino-consider din natin sa data ng runway yung slope or yung gradient ng isang runway. And another thing, minsan nagiging factor din, may mga runway tayo na located on mountain ranges, especially in Indonesia, I think Papua New Guinea, maraming runways doon. In mountain ranges na hindi natin kaya talaga na o hindi kaya na hindi mawalan ng slope ng isang runway. So therefore, we just provide limitation in order to mitigate this. So self-explanatory, we got 1% and 2%. 1% for code number 3 and 4. Again, naka-base siya sa Aerodrome reference code. 2% for code number 1 and 2. Sir, paano namin mako-compute yung percentage na to? So, by the way, meron din tayong mga another criteria here in conjunction with this. But ito yung magiging major natin na criteria or major reference. With the percentage, how do we compute it? So, of course, kaya tayo nagka-slope is mataas yung elevation ng isang part ng runway doon sa kabilang end. Kaya siya naging slope. In order to compute it, you just have to deduct yung dalawang elevation, two different elevation, and then divide it by the actual length of the runway. So for example, we got the elevation of the higher end ng runway dun sa isang end and yung kabilang end. So we got 4,400 and 4,370. So very, you could see yung elevation immediately, medyo mataas. So subtracting those end, we could get 30 feet. So 30 feet yung difference ng elevation. Um, Actually, kung iisipin natin, medyo malaki siya. However, masyadong mahaba yung runway natin. So, yung 30 feet na yon, medyo maganda yung pagka-slope nun. And yung pag-compute, magbe-base din tayo sa actual length. So, mababago pa. So, if we have 30 feet after subtracting, so take a note on this, divide natin yung length ng runway. Again, as I mentioned, magbe-base pa rin tayo with the length. Of course, pag maiksi yung length ng runway and may 30 feet ka na elevation, mataas yung slope mo. However, kung may 30 feet ka na elevation or difference, in a much longer runway, bumababa yung slope percentage. So basic trigonometry to. So we got the 30 feet difference. 30 feet divided by, for example, the actual length of the runway is 3,000. So 30 divided by 3,000, we could get yung slope percentage. And if we divide that, it will be 0.01. And you could see, mababa pa rin siya. Hindi siya lumagpas sa 1% or 2%. So, nahatak siya nung length of the runway. However, kung maiksi yung runway natin, again, tataas yung percentage. So, for now, 30, on my example, 30 feet divided by 3,000 feet will get 0.01%. So, that's an example for the actual slope of the runway. Another factor is yung sight distance. We need to consider yung makikita ng ating crew beyond the runway. We got the distances here, and you could see based again siya sa Aerodrome reference code. And of course, nakabase siya on any point above the runway. So yung taas. So nakita nyo sa mataas na reference code, C to F, 3 meters yung kino-consider, any 3 meters point above a runway. So bakit sir kaya 3 meters? And bumababa siya nung bumababa yung code letter natin. You would see 2 meters for B, 1.5 meters na runway sight on all other points above the runway. So same yan, 3, 3, 2, 2, and 1.5. Sir, bakit po bumababa siya sa pagbaba ng ating reference code? So this reference code, as you could remember, based siya yung code letter doon sa aircraft. So of course, pag bumababa yung ating reference code, lumiliit yung ating aircraft. And then, bumababa din yung sight distance. Since mas maliit ang aircraft, mas mababa ang elevation ng crew or ng pilot while sitting on the runway. And the more na lumalaki yung ating aircraft, tumataas yung code letter, tumataas naman yung elevation ng flight crew or ni pilot on the runway. Kaya tumataas din yung sight distance na kailangan natin. Next is transverse loop. Transverse slope, so kanina yung slope na pinag-aralan natin, ito yung longitudinal slope. So runway end to end. Ito namang transverse, ito yung sa width ng runway. We got the maximum, preferred, and the minimum for code letters A, B, and C to F. Maybe some of you have questions on their mind. Sir, bakit kailangan pa natin ng slope transversely or on the transverse side? So, ang primary purpose ng transverse slope is i-promote yung drainage or rapid drainage ng water doon sa runway. So, napakalaking obstacle and factor po na may water tayo doon sa runway. If you could remember, meron tayong presentation kung saan may chart. Nagbabari yung approach ng piloto and yung braking approach depending on the water presented on the runway. And we have slope transverse to promote yung drainage ng water para maalis rapidly as much as possible yung drainage or yung water doon sa runway. So next, So for strength of the runway, self-explanatory naman, dapat lang kaya niya i-withstand yung traffic and yung weight ng aircraft na intended i-serve yung runway. And of course, this will be going into the construction site na ng runway. Next is surface of the runway. We have a few things to consider here for the surface of the runway. Runway surface should be constructed without irregularities result on friction characteristics. So, kino-consider natin yung friction characteristic ni runway constructed to provide good friction when it's wet. So, in conjunction to kanina doon sa drainage procedures ng transverse flow. So, yan, friction characteristic ang number one consideration ng surface ng runway. Texture depth, minimum is 1.0 mm. Surface is grooved. So, may mga iba tayong runway in order to maintain yung friction characteristic is naka-groove siya. So, if you see, same with the cement type na kalsada, ginugroove yun. Yung groove, like parang process yun, parang sinusugatan para magkaroon ng additional friction doon sa pavement. So, parang nire-rake siya. Ang advice lang dito by the local authority is dapat yung groove or scorings na ilalagay is perpendicular sa runway center line. So, hindi siya dapat parallel or longitudinally groove, dapat perpendicular siya with our center line. Next up, we also have data here for runway shoulders. So, self-explanatory runway shoulder, yun yung part extending doon sa runway outside the runway edge marking. So, ito yung runway edge marking natin. We got shoulder extending on the side of the runway. And this is very common sa mga commercial airports natin. Very common and required. As you could see, required siya sa higher code letters na runway. So it started to D, E, and F. So sa mga smaller runways natin or airport, hindi siya nire-required. The primary use kung bakit nire-required ng local authority yung runway shoulder is to accommodate yung engine ng mga malaking aircraft. As you could see, if we have commercial operation or larger aircraft, yung engine po natin is nasa wing. Compared sa smaller aircraft, yung engine is within the alignment ng airframe. So, pag yung engine natin is nasa wing, if nag-take off si aircraft doon sa runway, yung engine natin will be protruding doon sa labas ng runway. So, yung shoulder, dinedesign yun to accommodate yung largest aircraft na ma-accommodate pa rin yung engine niya is within the shoulder. Sir, bakit pa kailangan sinesement yung shoulder sa commercial operation? Since yung engine natin will be outside the runway, and of course, kailangan sealed siya, asphalt or concrete, para ma-accommodate yung overhang engine and yung jet blast. So, imagine a runway accommodating commercial aircraft, large commercial aircraft na walang runway or surface runway shoulder. Pag nag-take off ka, automatically maximum power yan. Yung jet blast ng engine, uukain niya yung lupa nung or runway strip associated with the runway. So, kaya niyang ukain yun. Therefore, leading yung runway mo na into slowly destruction ng runway. So, of course, repeated issue, mauuka yung shoulder. If hindi siya cemented, then it will lead to the destruction of the runway. So that's the primary reason kaya nire-required yung runway shoulders to be cemented or asphalt or surface is to accommodate yung jet blast ng overhang engines ng mga large commercial aircraft. We have the data, of course, here. Moving forward, our runway strip. So we also have um, the runway strip. We have the law mandating the runway strip. Primary use ng runway strip is to accommodate any emergency. Typically or primarily any runway incursion. So pag nagkaroon ng problems ang crew operating on the center line of the runway, we could lessen the damage ng aircraft. Kaya may bakante tayong area here or the runway strip. And we got the data on the left side. So ito yung runway as you could see, and you could barely notice here na hindi siya pantay. So may slope tong runway na to as we have discussed. And you could see here on this side yung runway shoulder. So I think this runway accommodates commercial aircraft, at least one engine overhang on the runway to accommodate yung jet blast. Kaya cemented tong shoulder. And in conjunction, on the runway, may slope tayo sa runway transverse to accommodate water drainage. Yung ating runway strip, may mga given din siya na slope to accommodate yung drainage ng water. So sa isang aerodrome, sa isang airport, meron talaga yung nakadesign na location kung saan dapat itapon or mapunta yung water, especially on severe weather condition. So may spot talaga sila dyan for the drainage system. Next is yung runway and safety area. So we also have data here in terms also with the Aerodrome reference code. Self-explanatory naman. If the RESA or runway and safety area will be required. If you're not familiar with the runway and safety area, so it's the counterpart ng runway strip. So if the runway strip is yung extra space doon sa runway transversely, so yan yung runway strip. Ang runway and safety area naman po, extra space yan longitudinally sa harap ng runway. And required to accommodate then if may emergencies sa aircraft to lessen yung damage natin with the aircraft. And please wag malilito with the RESA, the clearway, and the stopway. Magkakaiba pa yon. So we'll discuss later yung stopway and clearway. Stopway yung extending yon sa runway natin, which is surface. Yung runway and safety area, no need for it to be surface, same as the runway strip. Kailangan lang may extra area tayo doon to accommodate any emergencies. So this is a very great presentation of the RESA and the runway strip. You could also see a marginalized here, maybe a presentation ng runway shoulders of this specific runway. There we go. Yan, we got the stopway and the clearway. Clearway and stopway, madalas na i-interchange to throughout the industry. So we'll discuss kung anong basic difference na. So on my presentation here, you got the data concerning about the clearway. Self-explanatory naman yung mga data provided or numbers provided. We got the stopway also. The primary difference of the stopway and the clearway is that yung stopway po, ito yung cemented part at the end of the runway. Ang primary use po ng stopway is to accommodate an aircraft in case of an aborted takeoff. And madalas yung aborted takeoff natin from time to time for many factors and reasons. And kaya siya surface is of course when we abort the takeoff, kailangan natin ng deceleration and we need a distance for deceleration. And yung stopway, it will provide additional distance for the crew or for the aircraft to abort the takeoff. And if you could remember sa declared distances natin on the previous topic, kasama si stopway on one of those distances. And also yung clearway, a different declared distance naman. Ang primary use ni clearway is to accommodate yung takeoff run available for that runway. So the clearway, hindi siya or no need siya to be surface. Kailangan lang clear siya for any obstruction. So ang clearway, as I mentioned before, possibly or pwede rin siya na bodies of water. So madalas ang runway natin is near sa bodies of water. Bakit madalas ang runway near sa mga bay? Of course, better performance, nasa sea level tayo. And madalas yung clearway, it could be a bodies of water. Needed lang na controlled area ito ng aerodrome operator. So walang any movement there, any obstruction in order to accommodate yung takeoff climb ng isang aircraft. So that is the clearway and the stopway. Next stop is yung radio altimeter operating area. So ang radio altimeter, or sometimes referred as radar altimeter, it provides an aircraft, especially mga commercial aircraft, to provide accurate reference. Nagagamit siya from at least an altitude of 2,500 feet. That's about above ground level. So from the airport, it can provide exact altitude ng sa aircraft. Remember that the altimeter or the standard altimeter ng isang aircraft are based sa pressure. So based siya or kumukuha siya ng data sa static port. Therefore, may mga discrepancies from time to time. Actually, if you operate an aircraft, makikita nyo na yung laki ng itinatalon ng altimeter when you change yung pressure sa sea level. So magkakaiba tayo ng actual pressure associated per airport, kaya kinukuha to every approach, takeoff and landing. And if you change yung QNH on the aircraft, makikita nyo na ang laki ng tinatalon ng altimeter in terms of the static pressure. Kaya for the safety of the operation, we use this radio altimeter to provide exact altitude for landing aircraft. Ang function or yung process ng altimeter or radio altimeter, so nagbabounce back siya ng signal from the ground and kinocompute to ng instrument getting back on the aircraft to provide an exact altitude. And may mga physical characteristics din tayo na sinusunod. Since accurate dapat tong radio altimeter, we have a certain distance provided on the airport for it. So we got a visual representation here. Just look into the visual representation, madali nyo siyang matatandaan. So, yan, take note on this. Radio altimeter should be 300 meters distance from the threshold. Yan, 300. Yung area niya could only be extended 60 meters laterally. 60 meters from left and to the right. So there we go. 300 meters again from the threshold and extending 60 meters laterally. That will be the physical characteristic of the radio altimeter operating area. Next stop, taxiway width and clearance, very self-explanatory. The width and the clearance, we got the numbers here in metric Nakabase siya sa OMGWS. Yung OMGWS, yun yung nasa Aerodrome reference code. Again, if you look back, that's the outer main gear wheel span. So, nandun siya sa code element A, B, C, D, and F. Sorry. Doon siya na kabase. So, yun yung ibig sabihin ng OMGWS. So, take a note on this. Outer main gear wheel span. Na-discuss na natin to before. There we got curves ng taxiway. Nakadepende siya sa design speed. So, we got the speeds here. Very self-explanatory. And the radius of the curve provided na. So, if you will construct a taxiway, kung ano yung speed na dinesign mo for the operation, and of course, nakadepende yung speed na i-design mo sa ika-cater mong aircraft, naka-base din doon yung radius ng curve. However, for this naman, very flexible. Any aircraft naman could go less speed to accommodate yung radius of turn. And nasa discretion naman na to ng pilot or operating ng crew on how they will address the radius. We also have, same as the runway, we also have slopes to consider for the taxiway, of course, to accommodate yung ating drainage ng water. So we got the given numbers here for the longitudinal slope of the runway. For code letter A, B, code letter C to F, and the transverse slope also provided na on this data. And same as the runway, we also have provided sight distance ng taxiway. Same as the runway, it's based on the code letter, and the minimum line of sight is 150 meters for A, and so on, 300 meters for C to F. And ito yung line of sight above the taxiway. Maybe you're wondering, sir, yung sa kanina po sa runway, wala po tayong line of sight na kailangan makita. Unlike dito sa taxiway, meron tayong 150, 200, 300. Doon po sa runway, if you will look back on the previous slide, naka-base po siya automatically half of the runway length. Let me get back it. There we go. Yan. Distance of at least half of the length of the runway. So take note on these numbers. Yan, pag taxiway na, we got designated numbers. Of course, taxiway, bearing strength, depending also sa accommodate niyang aircraft. Surface, same as the runway. With the width, ayan, given na yung width natin, numbers, depending on the code letter. Of course, depending again sa Aerodrome reference code. We have the data presented here. Taxiway on bridges. So we got some reminders here for constructing a taxiway on a bridge. The minimum width of the part of a taxiway bridge is capable of supporting the traffic that use the bridge. Must perpendicular also on the taxiway center line, not be less than the total width of the graded area of the taxiway strip. So if we got a taxiway on a bridge, supposedly kailangan kung ano yung width ng ating original taxiway, if it bypass doon sa bridge, it should be the same width on the graded or the surface part. Also, a bridge should be constructed on a straight section of the taxiway with a straight section on both ends to facilitate the alignment of the aircraft. So, of course, will be, or the operating, or the pilot or the crew will be operating the aircraft on the bridge wherein wala tayong room for error. So the law states na dapat ang pag-construct ng bridge of, or if you will have a bridge on a taxiway, kailangan nasa straight section siya in order to help the crew or the pilot to align themselves doon sa bridge. We have a law here with this sa CAAP, taxiway on bridges. However, I don't think na meron na tayo nito currently in the country. But hopefully, marami tayong construction ng airport, probably magkaroon na tayo ng mga taxiway on bridges. But now or presently, wala pa akong nabalitaan na constructed na ganito on our country. Common to sa Europe. Sa States, wala rin masyadong taxiway on bridges. More on sa Europe to since congested yung mga city airports nila. And they extend their operation sa ibang area or that area outside the airport. Kaya they have taxiways bypassing a road or any obstruction. Rapid exit taxiway. Also, another thing na hindi pa, I don't think na we have a rapid exit taxiway on the country. However, meron na tayong law mandating this. So we got the distances here per code number again for Aerodrome reference code. Ang primary use po ng rapid exit taxiway is to accommodate aerodrome operation pag meron tayong high volume ng aircraft. Para isa na lang yung exit ng mga aircraft and they could immediately clear the runway upon operation. Of course, if they could exit the runway as much as possible, we could or the ATC could land the next aircraft on a least amount of time. So kaya tayo may rapid exit taxiway. And hopefully, we could also build some of this in the future airport we are constructing on the country. Holding bay and runway holding position, we have a few limitations here. And we have the distance of the runway holding bay or runway holding position from the runway. And it's categorized depending on the approach type. Yung holding bay naman po, it's just an extra area on the runway and minsan meron din to sa taxiway right before the runway. Ang primary use po nito is to accommodate volume of traffic. So if we have a lot of traffic and then nagkaroon ng problema doon sa isang aircraft, of course, kunyari, sa isang operation, we line up this aircraft into the runway. Nagkaroon ng problema yung isang aircraft. Kunyari, nag-request yung crew, we need some delay or 5 minutes, 15 minutes delay to check on something, required, of course, ATC to approve that since it's a safety factor. And they uses a holding bay para ilagay or i-put up yung aircraft na may problema on the runway or in the taxiway from the meantime and to accommodate yung ibang departing or operating aircraft. So it's just an extra area located on a runway or a taxiway before the runway, but we still have guidelines in building. Next up is apron. So we also have guidelines on the apron. We got distances from the center line of the aircraft parking position, taxi lane to the object, and from the wingtip of the aircraft to an object. Maybe you're asking, sir, why do we need to distance the apron from certain objects on the airport? Usually kasi ang apron ay manage na ng operator, ng terminal building, or ng aviation company or ng isang FBO. or ng isang fixed base operator. Therefore, yung apron, since it serve as the parking of an aircraft, may discretion na si company doon sa parking or sa, of course, sa designated parking niya or terminal building. That's why we provide clearance from any objects. Kasi once you operate an aircraft, ang function ATC is once you are on the parking, wala, yun na yung final call nyo. So the final and the starting call always started on the apron. And the company you are operating or the aerodrome operator controls the apron. We also have the slopes here. Needed na at least not more than 1%. Bearing strength, of course, depending on the aircraft that it will cater. We also have here apron roads. So we got roads on the apron and to accommodate surface vehicle. Primary ina-accommodate nito is yung refueling team. So it's practicable. Vehicles traveling on it will be at least 3 meters from any aircraft parked at the aircraft park position. So that's the minimum distance, 3 meters. Taxiway and service road. So for large commercial operation, we got service road on the taxiway. It's the one who accommodates vehicle, trucks, and cargo operation sa isang commercial operation. So, lagi siyang parallel on the apron parking or on the taxiway. Lagi siyang parallel. So the surface vehicle will always be traveling parallel on the aircraft, mitigating any accident and to increase safety. I have a picture onwards for this. And we got 3 additional here. Hindi ko na siya dinagdag. Kasi doon sa lumang mga laws natin, nakalagay pa to yung iba dito, especially jet blast and de-icing facilities. However, when I check ka-up, yung revision ng mga laws mandating this, tinanggal na po yung part na to. Of course, I mean, you know naman the primary reason kung bakit tinanggal. Unang-una, we don't need any jet blast or de-icing facilities. Number one, de-icing facilities hindi naman natin needed on the country. So we don't need laws mandating for it. So moving forward, there we go. I got here on the right side yung surface or a service road on the taxiway. There you go. You could see the surface vehicle. It's probably from the local authority or on the airline. Traveling siya lagi parallel on the aircraft operation. Yan, example ng surface road. On the left side naman po, ito yung isolated aircraft parking position. Ito yung example. So, sir, bakit po tayo may isolated aircraft parking position? Mandated or designated per airport, especially on large commercial one. The primary use po nito is for emergency. So, number one, primary use talaga, kaya ginawa yung isolated parking position if meron tayong mga emergency call concerning terror attacks or any hijack or any passenger with regards to the safety of the aircraft. So, pag tinawag ni crew or ng pilot na we have some people concerned with the safety of the aircraft on their flight, automatic, the ATC will put them on the isolated parking area, especially if it's concerning for any terror attacks. That's the primary reason why they build this, especially after the 9/11 attack. However, naging useful din tong isolated parking area for the last 2 years nung nagkaroon ng COVID. So, if may mga planes tayo, reported cases, or may mga nakakalusot na COVID positive, naging useful din yung isolated parking area in order to accommodate yung mga gantong scenario. And you could see also here one of the examples of a service road. Next picture or next slide. I just have here presentation of a jet blast to accommodate yung engine ng aircraft, especially if yung end ng runway is nasa civilized part or may part doon na hindi control ng airport. We have here an example of the icing facility. No need for us to elaborate here. Hindi naman na to magagamit on the operation on our end or on our country. And that concludes our PowerPoint for today. Any question so far, guys, for the module number 1 for midterms? Go ahead. Okay, if wala nang question so far, that ends our discussion for 424. We're 10 minutes earlier than expected. Have a good day. Take your lunch and see you again later this afternoon. Have a good day, guys.
Thank you po.
Thank you, Ko.
Thank you po, sir.